So when I say the word radar, what probably comes to your mind is some kind of large dish-like device with 100 antennas looking for UFOs. And you wouldn't be wrong, but today I'm going to tell you about a different kind of radar that I'm using in my research. So my research is done partly in collaboration with Google's Advanced Technology and Projects Group, and they've managed to shrink traditional radar technology down to a miniature size called the Google Soli that's about the size of a penny. And because of its small size, the Soli can be integrated into most smart devices, such as your phones, your watches, your tablets, and speakers. And I've been exploring how we can utilize the Soli to interact with these devices using subtle gestures. And the motivation behind the emphasis on subtle gestures stems from the idea of designing socially acceptable interactions, where users don't feel self-conscious or shy to interact with their devices, especially in public places like in an office or in a bus. And my research presents three contributions. The first is a solution to a problem commonly referred to as Midas touch in gestural interaction, named after the mythical king Midas, whose touch accidentally turned everything to gold. So let me give you an example. Imagine your phone is equipped with a Soli radar and you're on an important phone call with your boss. You're on hands-free mode and suddenly a fly appears out of nowhere and you start erratically moving your hand around to swat away the fly. Your phone interprets this motion as a command to end the call, and now you just lost your job. So this situation highlights the Midas touch problem, where unintentional hand motions can trigger unintended commands and lead to unintended consequences. So in order to solve this problem, I designed a signal processing algorithm that's able to ignore hand motions that are used in daily life, but they're able to detect fast, deliberate hand motions. So these includes finger gestures such as finger rubs or taps, and even a simple pinch can be detected by this algorithm while ignoring all other common hand motions. My second research contribution was the curation of a data set specifically tailored for performing gesture recognition from radar data. So with the help of 8 participants, I gathered data on a wide variety of subtle hand gestures. And in order to validate the data set, I used deep learning for gesture classification and was able to achieve an accuracy of 87% in real-time performance. And this leads me to the final phase of my research, which is a user study where the gesture recognition models were implemented in 2 real-time applications on an Android tablet. The first application was a document viewer where participants could use subtle gestures to swipe through pages and even zoom in to specific parts of a document. And the second application was a media player where participants could use subtle gestures to control playback and see through different forms of media content like movies and YouTube videos and podcasts. And the feedback collected was very positive. Participants were able to correctly perform the gestures and found the interactions very intuitive. And they even favored the subtle gestures over larger motions, and many also preferred using subtle gestures over even touch screens and remotes. And in future work, we are also looking at embedding the Soli into the sleeve of a jacket.
Sorry, you'll have to stop there. It's a very strict 3 minutes, but thank you